Good morning, ladies and gentlemen. This live stream is part of a new series I want to start doing on Sundays where I do a little informal chat with you guys about the research I'm doing, and hopefully it's of a topic that you guys will be interested in. I'll be doing them at 9 a.m. on Sunday mornings. Today we're filming on the phone, and it's going to probably do that wiggly thing. The audio quality isn't great, but we're hopefully going to change that soon. So we're getting our first few people in, and I wanted to chat with you guys about motors. Now, ever since, long before I even bought this boat, I've been thinking about motors. But over the last few months, I've been doing a lot more research about electric motors and how to power a boat. And I wanted to share some of that with you guys. So we'll start with the cool stuff on the high end, and then we'll work our way down to reality again. So you know of Tesla, you know of all the other manufacturers making electric vehicles right now, and they basically fall into two different groups. We have Tesla doing a permanent magnet AC motor, also called an induction motor, and then you have everyone else doing brushless DC motors. That's the way it stands here in 2020. Very few people are touching the permanent magnet AC motors except for Tesla, and all of them are kind of breaking 100 kilowatts. So these are pretty big motors, and in order to get that level of efficiency and that level of power, they're cranking up the voltage. So back in the day, we had 48 volt electric cars, and that number has been climbing steadily. I think Tesla runs like 600 volts. I know that the Nissan Leaf is 284 volts or something like that. Anyway, the high voltage is definitely one of the ways that electric cars, anyways, have gotten that higher range and higher efficiency, because these motors tend to take high voltages to run very efficiently, because the cables and the windings are only so thick, right? So otherwise you need very, very thick cables. So all of that means, in those systems, those voltages, you can't use that voltage for anything else. You need a converter. I wanted to run my boat with the same voltage across the bar, because it being a marine application, me being in remote places, if something fails, I want to make sure that I don't lose half my systems or all of my systems just because a power converter fails. So I wanted to make sure that as many things ran on just pure battery voltage as I could. So I picked 48 volts, because you can still get some motors that run at 48 volts, and you can still get some household appliances like inverters and stuff like that run at 48 volts. So that was a sweet spot for me, but that posed a problem for when it came to my motor, because I couldn't just pull the motor out of any modern stuff. But of course, modern stuff tends to cost more, so you get what you get. So let's talk a bit about those motors. Let's talk about the brushless versions first, because those are what's most popular right now. Brushless BLDC, brushless DC motors. This one here is a Turnigy 100cc. This is an RC motor. It's designed right after, quadcopters. Quadcopters is the same design. They're called outrunners. So the outer casing spins on an inner casing. So that means on a BLDC, a brushless motor, the part that spins is the part that has the magnets. And then the part that doesn't spin in the center, that one has a stator. So that's what these three wires go down to. So this is a DC variant, but you'll notice there's still three phases to that DC motor. So the difference between this and a permanent magnet AC motor is, I still haven't figured it out, to be honest, but they do take different controllers. I know that much. So I haven't dived deep enough in order to figure out exactly what about those controllers makes them different. But needless to say, this particular one, because the magnets are on the outside housing, as it spins and gets hot, it pulls those magnets into the outer housing. So this one's capable of some really high RPMs. This housing is rated at 22,000 RPM. Now, the way it's wound, it tops out at something like 6,000 RPM instead. So for a electric motor conversion straight into it, this is not a bad option as long as you're running something pretty lightweight and you're running it for a short amount of time, because as you'll notice, there's no cooling on this motor. It's just an open housing. So that's an issue that you want to look at. How long are you going to run your motors, and what kind of strain are they going to be on under? When I first got the boat, I thought I was going to be able to power it off this tiny little thing, and the more I learned that that was wrong. Now, luckily, this wasn't a very expensive mistake, because this motor is $240, so it's definitely the cheapest motor for the power. This is 8,800 watts, and it only cost me 240 bucks. So I'm still going to be able to use it, but it's not the motor for my boat because of cooling it and its wear and tear and that kind of thing. So it can surge up to 9,600 or something like that, but honestly those surges are like seconds long, so you really don't get the kind of long consistent usage you want in a marine application out of a motor like this. So we're not going to use this one for that big boat project. What we are going to use, and what you'll see a video about on Wednesday, is this motor. This is a permanent magnet AC induction motor. This is the High Performance EV's AC12. Now, as you can see, much larger than that little Turnigy motor. Still, 3 cables coming out. So in a lot of ways, BLDC and permanent magnet AC are very similar. They are both brushless designs, and they're both applicable for remote applications like vehicles, anything that isn't going to be plugged straight into the grid. Because they have speed controllers that can split the DC power from a battery bank into the 3-phase power that they need. So this particular model is rated at 12 kilowatts and has surge capabilities as well, just like the other one. But unlike the other one, this one has continuous usage ratings that are much, much higher. So I'm able to run this, at 10 horsepower all day long if I want. So that is really big for my application. Now, unfortunately, this one is still air cooled. So I am looking at the option of trying to water cool this somehow, or set this up in such a way that it is safe for marine environment. But for the time being, this is what I've got. I got this at a Wicked Steel, so this system here with the charge controller is like $3,000 usually. So a lot more than that $240 motor. But of course I paid a little bit less for this, considering how dusty and dirty it is. So we'll get into that on Wednesday. But these high performance EVs is one of the big ones out there when it comes to induction for your electric vehicles. And then there's also Mote Energy does induction motors as well. They've been on the scene, I would say, longer than high performance EV. Their motors are of a different design. High performance EV tends to do a longer cylindrical motor, and they're really good for continuous usage. So they have like the AC9, AC12, AC35, well, they have an AC22, an AC34. They have a Siamese AC34, which is 2 of the AC motors side by side. And then they have an AC50, and the AC50 is like over that 100 kilowatt range. So that is some serious power if you wanted to convert like a full, family sedan or something like that. And that'd be what you're looking at. Now, I wasn't looking at this motor because this motor, like I said, is quite expensive. This is a bit more of the cat's meow. And the reason it's expensive is AC induction motors, good ones, permanent magnet ones, are really great for regen, and they're really great for efficiency. You get a lot of perks out of that. So you get better efficiency ratings by a few %, and you get better regen, which we'll see how much of a role that actually plays in my boat in the future. But for the time being, I wasn't really that concerned with it. So I was looking at a cheaper model because I just wanted to get moving and get going, and I'm really broke. So the idea of spending an extra, you know, $1,500 just to get those features just didn't appease me when I could buy a whole other motor, you know, for that kind of money. So the one I was originally looking at was a 10 kilowatt Golden Motors unit. Golden Motors makes some air-cooled and water-cooled variants. They're good for electric vehicles. They're a Chinese manufacturer. But you know, they've started blowing up on the scene, especially under the marine scene, because they have a lot of sealed units, which is nice. So I might end up getting one in the long run anyways, and then we can directly compare them, because I'll have two power legs and I'll be able to compare the efficiencies and real world applications. That would be amazing. So we'll get to that one day, or even other companies. Those are really, honestly, those are the DIY electric vehicle motor manufacturers that you'll hear of the most. There are a few other ones on that list, but then there's also the just like buy and drop in marine application electric guys. There's the Torqeedos, there's Ocean Volt, and then they make a good product. They make a high quality product. But I've got my own qualms with them. First of all, they're incredibly expensive. Just an outboard that is rated at 1/3 the horsepower of that motor would cost me 3 times what I paid for that motor. So actually, I got that motor and a bunch of other stuff, like all wrapped up in a deal. So it's actually even more than that. So like that $3,000 for like a you know, a little outboard that's rated at 4 kilowatts. That's what Torqeedo offers. And an Ocean Volt, I mean, you're looking at 10 grand when you want to get into the 10 kilowatt range, and that is a lot of money. It's great application if you've got the money and you don't want to learn all this stuff and you don't want to like spend months tinkering around with it and just to get it to work. You just want to drag it, drop it, like work your job in an office and then come out and run your electric boat. That's a great idea, because you know, they're foolproof systems and they're already pre-designed and they're well built. So no shade, the guys work hard, they do their thing. But for a guy like me who's consistently, you know, broke and is trying to learn all this stuff as he's doing stuff, it's just not attractive to me at all. And I'm assuming if you're watching my videos, it's probably not your thing either. Let's talk a little bit about other motors, because there are other motors you would like to look at. This is a brushed DC motor. This is the starter of my pickup truck, but this is actually a good idea. And well, not this particular one maybe, but brushed DC motors, don't count them out. I mean, they are older tech, and the efficiencies aren't as good as the brushless variants, but when it comes to putting torque on the ground, these things, like, you just can't compare it to a brushed DC motor. They put a lot, that electric torque that everyone's all on about. I mean, yes, it exists on other motors, but it's nothing compared to the brushed DC variants. These things just are astounding. And the amount of maintenance that these have is, like, honestly, not that much at all. It's more than an induction or a brushless motor, but there are plenty of people running around on brushed DC electric cars and other applications like that have run them for years without changing the brushes. This is not something you have to do very often, and honestly, it's not that big of a job. If you compare it to an internal combustion or a diesel engine, the amount of maintenance you have to do with that, changing brushes is like a couple of screws, couple of brushes, you know, maybe $100 worth of brushes, and you're done. So, like, really, in terms of maintenance, a million other things are going to break down your boat before your brushed DC motor does. So really, I wouldn't worry about that too much. There is the other reason that you might not want to look at brushed, is that there is the opportunity for sparks. And so that means that if you have any kind of combustible fuel on board, propane, gasoline, anything like that, you're going to want to not have the possibility of that gas or fumes get anywhere near one of these, because they will spark up and it will cause you to have a very bad day. That being said, I'm trying to run a completely fossil fuel free boat, so I am looking at reusing this motor, and I'll let you know how that goes in the long run. But honestly, for applications where you need a lot of torque, like say if you're running a winch, this is the kind of motor you want to look at because you know they're simple, they're cheap as chips. I got this one for free, and you can put a lot of power to the ground with one of these, and just don't count them out. Okay, just don't count them out because they are the cheapest option when it comes to electric vehicle conversions. Now, there's the other half of electric motors. Like there are a couple other ones I want to talk about. There's a purely induction motor, which I don't actually have one here. Oh, there's a grinder right there, a tabletop grinder that uses a purely induction motor. So that is two induction coils working on one another. So there's no magnets in that. The downside to those systems is they're designed to run directly off of alternating current. And any of the converters, you can get VFDs, variable frequency drives, that will convert single phase to three phase. So if you have a really powerful inverter on board, you could feasibly run that very powerful AC, like, 4,000 watts, 6,000 watts kind of range into a three phase and get yourself a few horsepower. And on my boat, I would be topped out at around 5 horsepower running it that way. It's something I might do in the long run because these motors are very, very cheap. But honestly, the inverter you need to run them, it's just like, it's incomparable. It's a huge amount of investment on the inverter. And yes, you save a bit on the motor. The VFD isn't that expensive, but like that inverter cost is gonna really hit you. So I haven't seen any mobile applications using a purely AC motor. I'm assuming it's possible. I run some AC motors on board to run like a table saw and other things like that, but they're all capped at 1,500 watts. So they're powerful enough, about 2 horsepower, but they're nothing compared to like a 12 kilowatt motor that I'm going to be running later on. So like I used to say, there must be a reason. I haven't found a way of powering one of those units with any mobile application direct from DC to AC converter of some sort that would be able to run that, because it uses a system that locks speed based on frequency. So if you're running at 60 hertz, it operates at a certain speed. If you're running 50 hertz, it operates at a certain speed. And because of that, that frequency has to be really well regulated. And I haven't seen leave it in the comments if you guys know of anything that'll do that, but I haven't seen anything that'll do that. There are brushed AC motors, like you find in power tools. Honestly, these kind of lack these are the worst of both worlds, other than that they're really, really cheap. They don't have the torque that the DC variants do often, and they don't have the maintenance free of the other induction motors. So I wouldn't really look at those too much in any long-term application, but I've been wrong before. I haven't seen anything like that. All right, I'm going to jump into some comments here. Oh, one last thing I want to talk a little bit about motors before we get sidetracked too much. You're going to be very careful about what some of these companies will claim in terms of horsepower. I would stick directly to watts, and I'll tell you why. When you deal with horsepower and torque figures, that is like a measure of power over time that a lot of people will fudge. So like you'll see a lot of companies go into like saying, oh, I have we offer a 10, like Torqeedo's renowned for this. They have their outboard motor, which is rated at 4 kilowatts, and they claim it's a 10 horsepower. Well, 4 kilowatts is like 5.5 horsepower. That's not 10 horsepower. 1 horsepower is like 756 watts or something like that. It's just stick to the watts and make sure that if you're looking at buying something and they say it's 30 horsepower or they say it's 20 horsepower, that you dig through all the paperwork and find the actual wattage, because Some companies will stay true to the facts, 5 kilowatts, 7 horsepower, sure. But then some companies will call their 5 kilowatt motor 30 horsepower. I've seen that plenty of times. And I don't know how they get off doing that and how there's no regulation to like stipulate that, or maybe they're jumping through some sort of legal hoop or something. But that motor will not perform 30 horsepower consistently the way you want it. You want to look at continuous usage, you want to look at surge usage, you want those watt figures, those amps going in, the gauges, the wiring. That's the kind of stuff that's going to actually be important for you. Yeah, just be careful when you're out there shopping, because there's a lot of people claiming something that they're not. Now I'm going to get into the comments right now. So we're 20 minutes into this rant, and finally getting into all right, Corwin states that the induction motor is different from the permanent magnet motor. Tesla uses both depending on the car. Corwin, are you referring to the induction? Because there are like BLDCs and AC permanent magnets. Both of them use permanent magnets, but they use them in different ways. I'm not entirely sure from the difference from the like, because they're both run by 3-phase. They just need different speed controllers, but I don't know why it's different or how it's different. Yeah, so this is what I'm saying. So Artix is on the same channel I'm at. So the BLDC motor is not really a DC motor because it uses 3 wires, and these 3 wires are on different phases. It is using alternating current by the time it makes it down here. But I think that the way that alternating current is wound and reacts with the magnets is very different from the way it's wound in this. So like you'll notice this one has a massive amount of poles, and those poles are wound in a very like specific kind of look. So they're up and down like this, wound. And if you look down the housing of this one, the windings are very different looking. So the way that interacts, and I think the way it goes is, instead of going up and down like this, they're like turned like this, if that makes any sense. So I think it's just turned, the wiring is turned a bit 90 degrees, and I think that is pivotal to the way that they perform differently. But in practice, honestly, they're very similar in most other respects. Lens RC Brushless Motors. Lens RC, there we go. It's this little self shout out. Okay, I get it, Len. So Lens RC says I should look up his Lens RC brushless motor. Will it run parallel to a flux capacitor? Porky, you're hilarious. Now everyone's on about the flux capacitors. Oh, it's been a long time since I've watched Back to the Future. See, I'm thinking about flux capacitors in my Minecraft server. Hey, Gypsy is a longtime viewer, see your comments all the time. Loves my coffee cup. You check that out. That is actually a couple of fins that came in that I dunked them in the ocean. You remember that a long time ago? They gave me this thing. It's called a kuksa. Oh, very, very good. Yeah, so you need to look into Sevcon. So Sevcon's another popular one. We can talk about motor controllers if you want for a second. We've got a few different ones. Hold on, I'll be right back. Okay. Show and tell. So this is a RC motor controller. Look how small this thing is. It's tiny. You got your DC input, and you got these 3-phase outputs, and then you got a little switch and a programming lead. So I'm able to plug that in to a computer and program it. I'm able to control the throttle with this little three cables at 5 volts, and then a little power switch like that. Really simple, really lightweight vessels. That's an option. Now, if you want to run lots of amps for lots of time, when it comes to electric motors, there's still a lot of heat produced, and the way of getting a motor to run a long time is having a good dissipation of that heat. So there's lots of other controllers. Curtis is one of the biggest names on the market. They've got a lot of units. They've also got a lot of knockoffs now. I can't tell you which ones or any of them work better than any others. I've never worked with any of them. I now have a Curtis one. I'll try it out. I'll let you guys know in the long run. Sevcon's also big on the scene. There is, God, I'm forgetting the names right now. There's a few other ones out there. Yeah, when you get into electric, you just got to be careful because there are ones designed for light duty, right? And there are ones designed for heavy duty, long-term continuous usage. So you want to keep that in mind as to what you're powering, how heavy it is, how long you want to run it. And that's going to make a big difference. Also, if you're looking at getting regen, either for a car, motorcycle, or boat, then you're going to want to get that in the controller. That's something the controller does. So those features are based on not only on the motor but on the controller. Okay. Theogra says, Theoga? I don't know how to pronounce that. Have you heard that there is a way to feed DC to a VFD? I just haven't figured it out yet. The VFD actually takes AC power and it converts it to DC power and modulates it to make it look like AC at different frequencies. Yeah, so what I was saying earlier is the only thing I've found for VFDs is there are VFDs that will convert single phase AC to three-phase. So if you don't have a three-phase input in your shop or whatever, and you want to power a three-phase motor, that's how you do it. I haven't found one that runs from a DC battery directly. I haven't found any way of doing that. So as far as I know, you still need an inverter separate to that. And that can run you a lot of money. Getting a 10 kilowatt AC inverter is serious cash. So it's pretty much out of the question for most people because the money you'll save from going induction, you'll lose again on the inverter. So you might as well just start looking at these direct from DC to AC induction motors, or a brushless DC, or a brushed DC even, because that is even less converting. You're going straight from DC to DC. Diesel wants to know how the weather is. Diesel, the weather today is fantastic. It was really good yesterday. We had a lot of wind, but we finally got some sunshine. So as you can tell, I'm really happy. I'm super ecstatic. Okay. Also, when looking at, Theoga also wants to know horsepower. RPM matters. 1800 RPM might be more useful than 3600 RPM. Yeah. So, they say that you get the torque and the power on a motor much earlier than you get it on internal combustion engines. You get that torque instantly, which is great, but it also means you have an amperage surge instantly. So when you put the throttle down, you're going to get like 500 amps to that motor. You better make sure the cables are ready to handle that. So there's that. The horsepower rating doesn't come in until a little bit later. So you do have efficiency and horsepower ratings that come out, and you'll see this in the graphs when you're looking at motors online. The graphs will show you at certain RPM, this motor is most efficient. You know, this is an 89% efficient motor at this RPM. The energy you can store on board is also much lower, so you need that efficiency to get where you're going. Because like one 20-liter, jerry can of gasoline has more kilojoules of power than a huge battery bank does. But so we can afford to run an internal combustion engine that all this fuel ready to burn, right? And it has massive amounts of power in it. So we can run it at low efficiency because, it's just an extra couple cups of gasoline that we're now. I can store 20 kilowatt hours of power on my boat, and that's a lot of juice compared to like your iPhone or something, but that's not a lot of juice compared to a gas tank. So I really got to stretch that stuff out as far as I can. All right, let's get into how do you intend to drive the boat with these motors, drivetrain and prop? Peter wants to know. Peter, the drivetrains I've actually covered in a video a while ago. I had them custom made in a factory out of China and shipped over. It was way, way cheaper to have these things made. They would have cost about 10 grand, the ones I was looking to build. I had a few other options. I could have put a prop shaft through my boat, but there was no setup for that originally in the original design. And that would have also meant that I probably would have lost the beachable aspect of my boat, which is a pretty nice thing to have. I'm still on the fence as to whether or not that was a good call. I spent a lot of money making these the mounts. I think I spent $2,700 building these two legs, but they would have cost almost 10 grand each to get them manufactured here in Canada. And every like machine shop I talked to and every fabricator I talked to wasn't interested in doing it. So I couldn't find anyone to do it. I tried designing stuff myself and I couldn't get anything that was rated at the power to consistently put down, like 30 horsepower into the water and just like mash on it all day long. Everything I was building wasn't strong enough. So I reached out to a factory that builds units similar to mine, but different in many key aspects for the Southeast Asian market. And they build these units to put big